Hey there! Ever feel like scientific breakthroughs are coming at us faster and faster? Well, get this. We're about to dive into how AI is basically hitting the turbo button on discovery, and it's already changing the game in some really cool ways.
It's true. What's so fascinating is how AI is pushing us beyond those incremental steps we're used to in science and towards these huge leaps forward, almost like science fiction is becoming reality.
Right. To really understand this, we're taking a deep dive into a recent Google DeepMind podcast episode. They had experts like Professor Hannah Fry and Pushmeet Kohli, the head of scientific research at DeepMind, talking about all of this. We're getting insights straight from the source.
It's a fantastic peek behind the curtain of how these breakthroughs are happening.
Okay, so where do we even start? Well, imagine spending years, maybe even a decade, wrestling with a scientific problem, only to have AI swoop in and crack it practically overnight. That's exactly what happened to a biologist studying protein folding.
It's a great example of the power of AI in action. You see, proteins are like tiny machines that carry out all sorts of essential tasks in our bodies and in every living thing. But understanding how they work depends on knowing their 3D structure. For decades, figuring that out from their building blocks, the amino acids, has been a major challenge.
So it's like trying to build a ridiculously complex Lego model without the instructions.
Exactly. But then along came AlphaFold, DeepMind's AI system. It's designed to predict these complex protein structures with incredible accuracy, often in a fraction of the time it would take a human.
And for that biologist who'd spent years on the problem, AlphaFold essentially handed them the solution on a silver platter. It's incredible to think about how much faster this could make scientific research.
It's not just about speed either. Think about the implications. If we can understand protein structures better, we can start to design new drugs, therapies, and materials with incredible precision.
So we're talking about potential breakthroughs in medicine, materials, science, you name it. This isn't just about understanding life, it's about potentially improving it in countless ways.
You've hit the nail on the head. What's even more remarkable is that this is just one example of how AI is changing the scientific landscape. DeepMind isn't limiting itself to biology. They're applying these same principles to tackle other complex systems, even something as unpredictable as the weather.
Right, like their GraphCast model, which seems to be giving those traditional supercomputers a run for their money when it comes to forecasting. I mean, predicting the weather accurately is no easy feat, right?
Absolutely. Traditional weather models require immense computing power, and even then they can sometimes be off. But GraphCast takes a completely different approach. It uses machine learning to analyze vast amounts of weather data and make predictions with impressive accuracy, often using less computing power in the process.
Yeah, they mentioned in the podcast that GraphCast actually predicted Hurricane Lee's landfall days earlier than some traditional models. Imagine what a difference those extra few days could make in preparing for a major storm.
It could be life-saving. More accurate and timely forecasts could give people more time to evacuate, secure their homes, and ultimately could save lives and protect property.
So from the tiniest proteins to massive weather systems, AI is proving it can handle incredibly complex challenges.
Yeah.
But what really blew my mind was how DeepMind is using AI to invent entirely new materials, which sounds like something straight out of a science fiction movie.
It does, doesn't it? For centuries, we've relied on accidental discoveries or painstaking trial and error to find new materials.
Right.
Think about the discovery of vulcanized rubber, or even something as revolutionary as graphene. Those were often chance occurrences.
Happy accidents that changed the world. But now we have AI entering the scene.
Precisely. And this is where it gets really exciting. DeepMind has developed an AI model called GNNME. It stands for Graph Neural Networks for Material Exploration, and it's already shaking things up.
Okay, I have to admit, when I hear graph neural networks, my brain goes a little bit cross-eyed.
Right.
But the results speak for themselves, right?
Absolutely. To really grasp this significance,
Yeah.
you have to understand that until recently, we only knew about roughly 50,000 stable materials.
Okay.
These are the building blocks of everything around us,
Right.
from bridges to smartphones.
So 50,000 known recipes in the cookbook of human invention.
Exactly.
I got it.
Now, GNNME has already identified a staggering 2.2 million potentially stable materials.
Wow.
That's like discovering an entire library of new recipes, most of which we've never even dreamed of before.
Whoa. That's not even doubling or tripling our knowledge. It's like multiplying it by, what, almost 50? That's mind-boggling. What can we even do with all these new materials?
That's the million-dollar question. Each of these materials could have unique properties, with the potential to revolutionize entire industries. Imagine lighter and more powerful batteries for electric vehicles, super efficient solar panels, or even materials with properties we haven't even begun to imagine.
It's like suddenly having access to a whole new toolbox for solving some of the world's biggest challenges. Energy, sustainability, you name it.
That's the beauty of it.
Yeah.
And while GNNME's primary focus right now is identifying stable materials, the DeepMind team is already working on refining it to predict other properties, like conductivity and durability.
Okay.
Still early days,
Yeah.
but the potential is enormous.
It's really exciting to think about. It's like we're on the verge of a materials revolution. But hold on. AI predicting protein structures, forecasting hurricanes, inventing new materials. Is there anything it can't do?
Well, it's interesting you should ask that.
Okay.
DeepMind is also exploring how to use AI in another area we typically associate more with creativity than with hard science.
Yeah.
Language.
You mean like those large language models we hear so much about, ChatGPT and all that? I've been playing around with those. And I have to admit, they can be pretty mind-bending.
They certainly are.
Yeah.
And while they might seem more like party tricks than scientific tools at first glance, DeepMind is uncovering some incredible applications for them in scientific discovery.
Really? So it's more than just asking AI to write you a poem in the style of Shakespeare, which, don't get me wrong, is still pretty impressive.
Oh, absolutely. Think about this.
Yeah.
Scientific knowledge is exploding.
Yeah.
Every year, thousands upon thousands of research papers are published, each filled with data, analysis, and conclusions. It's impossible for any one person to keep up with it all.
Yeah. It's like trying to drink from a fire hose of information.
Exactly. But imagine having an AI assistant that could read and understand all of that research, connect the dots between different papers, and highlight the most important findings. That's one way DeepMind is using large language models.
So it's like having a super-powered research librarian who can instantly pull out the most relevant information from this massive sea of data.
That's a great way to put it. But it goes beyond just finding information. These models can also start to analyze the data itself, looking for patterns and connections that human researchers might miss.
Okay. That's where it starts to get really interesting. So we're talking about AI not just helping us keep up with the pace of research, but potentially leading us to completely new insights.
You got it.
Wow.
And it gets even wilder. DeepMind is also using these large language models to actually discover new algorithms.
Really?
They have a project called FunSearch, short for function search, that's tackling some pretty complex problems.
Function search, huh? Okay, break that down for me.
Okay.
I'm intrigued, but I need a little help wrapping my head around what that even means.
Imagine giving the AI a problem to solve, something with real-world applications, like figuring out the most efficient way to pack a bunch of boxes. Sounds kind of mundane, right?
Well, as someone who frequently ends up with half-empty boxes after a move, maybe not so mundane, but I get your point.
Right. But this bin packing problem, as it's called, has applications in logistics, shipping, even things like cloud computing.
Yeah.
It's about optimizing space and efficiency.
Okay, so there's some serious real-world application behind this seemingly simple problem.
Right.
So how does FunSearch actually find these solutions?
That's where the language model comes in.
Okay.
It generates potential solutions, but not just random guesses.
Right.
It uses its understanding of language and code to actually write algorithms. It's like having the AI brainstorm solutions for you, but instead of just ideas, it's spitting out actual lines of code.
Whoa. That's next level. But how do they know if the algorithms actually work? Like, does someone have to test each one individually?
That's the really clever part.
Okay.
FunSearch has a built-in truth detector, so to speak. It's called an evaluation function. Essentially, it tests each algorithm it generates to see if it actually solves the problem effectively.
So it's like a constant cycle of trial and error, but at lightning speed.
Exactly. And what's remarkable is that it actually works. FunSearch has already discovered new, more efficient algorithms for
So we're talking about AI not just finding answers,
Right.
finding answers that are even better than what we could come up with on our own. That's kind of humbling, isn't it?
It really is. And it highlights this fascinating aspect of how large language models work. They don't think exactly like we do.
Right.
They see these vast webs of information and make connections that we might miss.
Yeah.
Sometimes those connections lead to what we might call hallucinations, outputs that might not be factually accurate,
Right.
but still spark interesting ideas.
I've seen that happen with ChatGPT. It's like it goes off on a tangent that's sort of related and
Yeah.
not quite right.
Yes, and while those hallucinations can be problematic in some contexts, DeepMind is finding ways to harness them for good. Instead of dismissing those unexpected connections, they're exploring where they might lead.
It's like they're saying, hey, even AI's mistakes can teach us something. I kind of love that. But this whole idea of using language models in science, it feels like we're just scratching the surface of what's possible.
I completely agree. In the podcast, Pushmeet Kohli talked about how DeepMind sees these breakthroughs as just the beginning. They're constantly looking for those root node problems, the ones that, if solved, could unlock even bigger advancements in the future.
So each discovery is like opening a door to a whole new set of possibilities, which lead to even more doors and so on. It's
Yeah.
like that infinite library in Interstellar.
That's a great analogy. And what's so inspiring is that DeepMind isn't just focused on the technical achievements. Pushmeet talked about how driven he is by the potential impact of this work, how AI can help us understand the universe, the very nature of life itself.
It gives me chills just thinking about it. I mean, it's one thing to create an AI that can write a catchy jingle or even write code, but to build one that could unlock the secrets of protein folding, invent revolutionary materials, or help us predict natural disasters, that's a whole other level. It's like we're not just exploring new frontiers, we're creating them.
It's a truly remarkable time to be alive, to witness this kind of scientific revolution unfolding before our eyes. And I think what makes it so exciting is that AI isn't replacing human ingenuity, it's amplifying it. It's allowing us to ask bigger questions, explore more possibilities, and hopefully create a better future.
It's like we're giving our collective scientific curiosity a superpower. But with all this potential, there must also be challenges. I mean, these technologies are incredibly powerful, so we need to be thoughtful about how we develop and use them, right?
Absolutely. Pushmeet emphasized the importance of responsible AI development and the need for strong ethical guidelines. He talked about the importance of collaboration between scientists, policymakers, and the public to ensure that these technologies are used for good.
It makes sense. We need to make sure we're asking the right questions,
Yeah.
considering the potential consequences, and making sure these advancements benefit everyone.
Exactly. And that brings us to what might be the most important takeaway from all of this.
Okay, I'm ready. What's the question we should all be asking ourselves?
If AI can already achieve all of this, and we've only just scratched the surface, imagine what will be possible in the next decade, the next century. What scientific mysteries will we unlock? How will these breakthroughs change our understanding of the universe and our place within it?
It's almost too much to fathom, but it's also incredibly inspiring. It's like we're standing at the edge of the unknown, and AI is giving us the tools to explore it like never before.
That's the beauty of a deep dive like this.
Yeah.
It's not just about the information we've uncovered. It's about the sense of wonder it sparks, the questions it makes us ask, and the possibilities it opens up.
Absolutely. And on that note, to our listeners out there, we leave you with this. Keep exploring, keep asking those big questions, and never lose that sense of awe and curiosity about the world around us, because who knows what incredible discoveries await us just beyond the horizon.
Well said.
That's a wrap on this deep dive into the future of science. Thanks for joining us.